Hello everyone. Yesterday I completed up to 6th sum in your exercise 7.1 of coordinate geometry 10th class textbook. Okay, that is 7th chapter of your maths textbook. From 7th onwards I'll tell now. So look at here, what is the 7th problem? This all the exercise which deals with only distance formula, is it? Okay, so 7th sum, that is prove that the points -7, -3, 5, 10, 15, 8, 3, -15 are taken in order or the corners of a parallelogram. We have to prove that the given points which forms a parallelogram. Okay, first of all we have to write, given that the points are A -7, -3, B 5, 10, C 15, 8, D 3, -5. What is the properties of this parallelogram? Is it a parallelogram? Yes. Why? Because here the opposite sides are equal, just like the rectangle, but the diagonals are not equal. In rectangle it is a parallelogram. Okay, here all opposite sides, not all, opposite sides are equal. What are opposite sides? A, B, C, D. What are opposite sides? AB is equal to CD, and also BC is equal to AD. These are the opposite sides. So opposite sides are equal and diagonals are not equal. In rectangle opposite sides are equal and diagonals is also equal. Only the difference between this rectangle and the parallelogram is the diagonals are equal in rectangle and the diagonals are not equal in parallelogram. What are the diagonals? This AC and BD. AC and BD are not equal. This we have to prove by using of this distance formula. First of all we will check this one. Okay, so for that I am taking the distance between AB. What is A? -7, -3. What is B? 5, 10. Let us take these values as x1, y1, x2, y2. So what is the distance formula? x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of, what is x2? 5 minus of -7 whole square plus what is y2? 10 minus of -3 whole square. That implies square root of 5 plus 7 whole square plus 10 plus 3 whole square. That implies square root of 12 square plus 13 square. That implies square root of 12 square means 144, 13 square means 169. That implies square root of, by adding of these two you will get 3, 1, 3. Square root of 313 units. That is AB. Okay, second BC. The distance between BC. What is B? 5, 10. What is C? 15, 8. Let us take these values as x1, y1, x2, y2. What is the distance formula? As usual, x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of 15 minus 5 whole square plus 8 minus 10 whole square. That implies square root of 15 minus 5, 10 square plus 8 minus 10 minus 2 whole square. That implies square root of 100 plus 4, that is equal to square root of 104 units. It is BC. Third one, that is distance between C, D. That implies what is C? 15, 8. What is D? 3, minus 5. Let us take these values as x1, y1, x2, y2. What is the formula of distance? x2 minus x1 whole square plus y2 minus y1 whole square. Square root of what is x2? 3 minus 15 whole square plus y2 means minus 5 minus 8 whole square. That implies square root of minus 12 whole square plus minus 13 whole square. That implies square root of 144 plus 169. That is equal to, when you add these two, 313 units. Just like the first one, right? These two are opposite sides. Look at here, AB is equal to CD is proved. Now we have to check this AD. Yes. So fourth one, distance between A, D. What is A? What is A? Minus 7, minus 3. What is D? 3, minus 5. Let us take these values as x1, y1, x2, y2. So many of the students, they are confused about writing this coordinates. That is, some of the students, I noticed so many times, that is, some of the students, they are writing this x1, x2, y1, y2. That is not correct. Okay, the first coordinate is x, second coordinate is y. Always you just remind that is x1, y1, x2, y2, not it is x1, x2, y1, y2. Okay. So what is the formula? x2 minus x1 whole square, y2 minus y1 whole square. That implies square root of 3 minus of minus 7 whole square plus minus 5 minus of minus 3 whole square. That implies square root of 3 plus 3 minus of minus plus 7 whole square plus here minus 5 minus of minus plus 3 whole square. That implies square root of 10 square plus minus 2 whole square. That implies square root of 100 plus 4. That implies square root of 104 units. Here the opposite sides are equal. Look at here. Here it is the second one, that is square root of 104 units. Here also we got the same answer, right? Now we have to check the diagonals. Is it equal or not equal? Okay. So about the diagonals. What are diagonals? The first one is distance between A, C. What is A? What is A? Minus 7, minus 3. What is C? This one, 58. Let us take these values x1, y1, x2, y2. Distance formula as usual. That implies 15 minus of minus 7 whole square plus 8 minus minus 8 minus 3 whole square. That implies square root of 15 minus of minus plus 7 whole square plus 8 minus of minus plus 3 whole square. That implies square root of 22 whole square plus, by adding of these two, you will get 11 square. That implies square root of 22 square means 484 plus 11 square means 121. That implies when you add these two, you will get 605 units. Okay, by adding of these two, you will get this one, 605 units. What is the second diagonal? Distance between B, D. What are B, D values? Okay, B value is 5, 10. D value is 3, minus 5. So let us take these values as x1, y1, x2, y2. What is the distance formula? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of here 3 minus 5 whole square plus minus 5 minus 10 whole square. That implies square root of here minus 2 whole square plus minus 15 whole square. That implies square root of 4 plus 15 square means 225. That implies square root of, by adding of these two you will get 229 units. Is the diagonals are same? No, these two are different. Here, this is conclusion. Here from above, the opposite sides are equal. That is, AB is equal to CD and also BC is equal to DA. But the diagonals are not equal. That implies AC is not equal to BD. Hence, it forms the points forms a, or the vertices of a parallelogram. Okay, it was the conclusion. That is the solution for this seventh sum. Next, here 8th sum. Show that the points, here 4 points he was given, that is taken in order or the vertices of a rhombus, and also we have to find out its area also. Here he gave hint, that is area of the rhombus is equal to half product of its diagonals, and also we can write it as half d1 into d2. This is the formula for area of a rhombus. First of all, we have to prove that the given points or the vertices of a rhombus or not. What is the properties of a rhombus? What is the difference between the square and rhombus? For the square, all the sides are equal. For the square, all the sides are equal, and also the diagonals is also equal. But for the rhombus, all the sides are equal, but the diagonals is not equal. For the square, all the sides are equal. For the rhombus, all the sides are equal. But what is the difference between these two? For the square, the diagonals are equal. For the rhombus, the diagonals are not equal. This is the property we have to prove. Okay, so let us write. So 8th sum, given that the points are A minus 4 comma minus 7, B minus 1 comma 2, C 8 comma 5, D 5 comma minus 4. So first of all, rhombus we have to draw. Okay, so for this, all sides are equal, diagonals are not equal. Okay, diagonals are not equal. First we have to prove this. So first one, what are the sides A, B, C, D, right? So distance between AB. What is A? Minus 4 comma minus 7. What is B? Minus 1 comma 2. Let us take these values as x1, y1, x2, y2. Okay, x2, y2. What is the distance between the formula? x2 minus x1 whole square plus y2 minus y1 whole square. That implies substitute these values, minus 1 minus of minus 4 whole square plus 2 minus of minus 7 whole square. That implies square root of minus 1 minus of minus plus 4 whole square plus 2 minus of minus plus 7 whole square. That implies square root of 3 square plus 9 square. That implies square root of 9 plus 81. That implies square root of 90 units. It is the first one. Second one, distance between B, C. What is B? Minus 1, 2. What is C? 8 comma 5. Let us take these values is also as x1 y1 x2 y2, that is x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of x2 8 minus of minus 1 whole square plus 5 minus 2 whole square. That implies square root of 9 square plus 3 square. That implies square root of 81 plus 9, that implies 90 units. So next two sides also we have to check. That is third one, distance between C, D. What is C? 8, 5. What is D? 5, minus 4. So let us take the values as x1, y1, x2, y2. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of x2 minus x1 5 minus 8 whole square plus y2 minus y1 means minus 4 minus 5 whole square. That implies square root of minus 3 whole square plus minus 9 whole square. That implies square root of 9 plus 81, that implies square root of 90 units. It is third one. Now fourth one, distance between D, A. That implies D. What is the value? 5 minus 4. What is A value? Minus 4, minus 7. Let us take these values as x1, y1, x2, y2. What is the distance formula? x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of x2 minus x1 whole square minus 4 minus 5 whole square plus minus 7 minus of minus 4 whole square. That implies square root of minus 9 whole square plus minus 7 plus 3 plus 4 whole square. That implies square root of 81 plus minus 3 whole square. That implies square root of 81 plus 9, that is equal to 90 units. These are the four sides. All the four sides we got as same equal answer. Right here it is square root of 90, square root of 90, square root of 90, square root of 90. All the sides are equal. Now we have to check the diagonals. What are diagonals? The first one is distance between AC. What is A? Minus 4, minus 7. What is C? 8, 5. x1, y1, x2, y2. Let us take the distance formula. x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of 8 minus of minus 4 whole square plus 5 minus of minus 7 whole square. That implies square root of here 8 plus 4 whole square plus 5 plus 7 whole square. That implies square root of 12 square plus 12 square. That implies square root of 144 plus 144, that is equal to square root of 288 units. The first one is square root of 288 units. And the second one, second diagonal, that is distance between B, D. What is B? Minus 1, 2. What is D? 5, minus 4. Let us take these values as x1, y1, x2, y2. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of 5 minus of minus 1 whole square plus minus 4 minus 2 whole square. That implies square root of 5 plus 1 whole square plus minus 6 whole square. That implies square root of 6 square plus 36. That implies square root of 36 plus 36. That is equal to square root of 72 units. Here it is the second diagonal. Here from above all the sides are equal. That is AB is equal to BC is equal to CD is equal to DA. But the diagonals are not equal. That is, AC is not equal to BD. Hence, the points or the vertices of a rhombus. Okay, but next what we have to find out? Find its area. If it is rhombus, then we have to find out the area. Now we have to find out the area of a rhombus. That is equal to half diagonal 1 into diagonal 2. The product of diagonals. Half into square root of, what is the first diagonal value? Square root of 288. 288 into square root of 72. Okay. So half into, look at here, this 288, we can write this as 4 into 72. When you are doing the multiplication of these two, you just look after here. 72 into 4, 4 2s 8, 7 4s 28. Okay, for 28 we can write this number as 72 into 4. So I can write this number as 72 into 4 into 72. That implies half into, I want to separate these two. 72 into square root of 4 into square root of 72. So here two square root of 72's are there. Half into square root of 72 whole square. 2 is there, no? That's why I wrote like this. So square root of 2 square. 4 we can write this as 2 square. Square root cancel. Here also square root cancelled. So half into 72 into 2. 2 cancelled. Then 72 square units. Square units. Why I am writing here square units? That is, when we are find out this areas, then we have to write out this square units. Okay. So it is the answer for this area of a rhombus. Up to here you have to find out. Okay. Then now it's time to explain this ninth sum. It is homework for you. Why? Because you have to check the given sum. First sum, you just look after here how many points we have. 4 points. These 4 points which forms any quadrilateral. That is, maybe it's a square, maybe it's a rectangle, maybe it's a rhombus or parallelogram or trapezium, right? What is quadrilateral? Name the type of quadrilateral formed. So every sum you have to do by just like the above. Just like the above sums, you have to check which quadrilateral it was. What are the quadrilaterals? What are the quadrilaterals? If the points which forms a or the vertices of a square, so what are the properties of the first quadrilateral, that is square? All the sides are equal. Sides are equal. Okay, and diagonals is also equal. Is also equal for this. So sides are equal and diagonals is also equal. For a rhombus, what is second? That is, for a rhombus, all sides are equal. Sides are equal, but diagonals are not equal. Okay, so all sides are equal. What is the difference between these two? Only diagonals. Here diagonals is also equal, here diagonals are not equal. What is third one? Rectangle. So for a rectangle, opposite sides are equal. Diagonals is also equal. For a rectangle, opposite sides are equal. Opposite sides means this one. This one. Okay. These opposite sides are equal. And diagonals is also equal. What is the difference between with the parallelogram? So, in this, opposite sides are parallelogram. Opposite sides are equal, but diagonals are not equal. Only the difference is diagonals between this rectangle and parallelogram. The last quadrilateral, that is trapezium. Okay, what is that? Trapezium. Opposite sides is also not equal. Only the height which is have this trapezium. The opposite sides are not equal. If the opposite sides are not equal, all the sides is not equal, then it is a trapezium. Then it is a trapezium. Okay. So just like that, you have to check for each and every problem of this ninth one. First sum, second sum, third sum. You have to check which is these points which forms a square or a rhombus or a rectangle or a parallelogram or a trapezium. You have to check it and you just give the conclusion for these points as usual for the second sum and third sum. Okay, just like the 7th and 8th sum, you have to do these 3 sums in the 9th Roman. Next, 10th sum. You just look after here. What is 10th sum? Find the point on x-axis. Find the point on the x-axis. Already I said no. On y-axis, what is the coordinates? 0, x coordinate which becomes 0. When the point which lies on y-axis, then the x coordinate which becomes 0. Here the point which lies on x-axis, then y coordinate is 0. So hence look after here. Given that the given points are A 2, minus 5, B minus 2, 9. But the point which lies on x-axis, it is x-axis. The point which lies on x-axis. When the point which lies on x-axis, the y coordinate which is 0. Y coordinate is 0. That's why I am taking this point P as x, 0. And here we have 2 points, that is A and B. These two are equal distance with point P. Equal distance. These 2 points are equal distance with AP and BP. These two are equal. Okay. These two are equal distance. So hence let the point P, that is x, y, which lies on x-axis. And is equidistant with A and B. So AP is equal to BP. Okay, AP is equal to BP. Hence that implies what is A? Distance between AP is equal to distance between BP. What is A? A is 2, minus 5. P x, 0. Here B minus 2, 9. P x, 0. Let us take the points as x1, y1, x2, y2. Here also x1, y1, x2, y2. What is the distance formula? x2 minus x1 whole square plus y2 minus y1 whole square. Here also square root of x2 minus x1 whole square plus y2 minus y1 whole square. We just substitute these values in this formula. Then you will get square root of x minus 2 whole square plus 0 minus of minus 5 whole square is equal to square root of x minus of minus 2 whole square plus 0 minus 9 whole square. Squaring on both sides. So that implies square root of x minus 2 whole square plus 5. And here 0 minus of minus plus 5 square whole square. is equal to square root of x plus 2 whole square plus minus 9 whole square whole to the power of square. Square root cancel, square root cancel. That implies it is in the form of a minus b whole square, a square plus b square minus 2ab plus 5 square means 25. Here a plus b whole square, a square plus b square plus 2ab. Just like the formula I am writing here. So here minus it becomes plus. Why? Because even number is there in the power. So 9 square means 81. That implies I want to bring all this into one side. X square plus 4. 2 square means 4 minus 2 2's 4x plus 25. So minus x square minus 4 minus 4x minus 81 is equal to 0. Okay, here plus x square minus x square cancelled. Plus 4 minus 4 cancelled. Here these two are minus. So same sign. That's why we have to add, but we just write this minus as usual. Minus 81 plus 25. Okay, 81 minus 25 minus 56, that is equal to 0. That implies minus 86 is equal to 56. That is equal to x is equal to 56 minus 8. When you cancelled this, that is 7 times. That implies x is equal to minus 7. Then what is the point? The point which lies on x-axis is x comma 0. That implies p of minus 7 comma 0. Here it is the solution for this 10th sum. Okay, now it's time to explain this 11th sum. So what is the 11th sum? If the distance between 2 points x comma 7 and 1 comma 15 is 10. Already he gave that the distance between the 2 points is 10. And we have to find out the x value which is present in the first point. Okay, we have to find out the value of this x. Let us write. So given that the points are a x comma 7, b 1 comma 15, and the distance between AB is equal to 10 units. That implies we have to find out this x and y, no, x value, no. Hence distance between AB is equal to a x comma 7, b 1 comma 15. Let us take these values as usual, x1 y1 x2 y2. What is the distance between AB? Already he was given, right? 10. That implies what is the formula of this? x2 minus x1 whole square plus y2 minus y1 whole square. That implies 10 is equal to square root of 1 minus x whole square plus 15 minus 7 whole square. Squaring on both sides. Okay, squaring on both sides. What you will get? 10 square. That implies 10 square is equal to square root of 1 minus x is there and 15 minus 7 is there. 8. 15 minus 7, 8 square. Okay, 1 minus x whole square plus 8 square whole square. Squaring on both sides, no, that's why. So square root cancelled. 10 square means 100. That is equal to 1 minus x whole square means it is in the form of a minus b whole square. A square plus b square minus 2ab plus 8 square means 64. That implies 100 is equal to 1. 1 square means 1 plus x square minus 2x plus 64. Just bring this all into one side. That implies, so I want to bring this 100 into other side. Okay, so here plus x square is there minus 2x plus 64 plus 1 65 minus 100 is equal to 0. That implies x square minus 2x. When you subtract from the 100 65 into from the 100, then you will get, so 100 minus 65 minus 35, that is equal to 0. So here we get one quadratic equation. From the third chapter I already said to you, that is quadratic equation. I am taking this how factorization, right? So minus 35 x square. When you multiply these two, you will get minus 35 x square. So 7 5s 35. X into x, x square. So minus I want to keep this minus in front of this highest number. So x square minus 35 is equal to 0. From these two, I will take the common term as x, that is 7, plus 5x minus 7, that is equal to 0. From these two, we have the common term it as x minus 5, x plus 5, that is equal to 0. So that implies x minus 7 is equal to 0. We just equate these two with the 0. So x plus 5 is equal to 0. X is equal to 7, x is equal to minus 5. Okay, it is a solution for this 11th sum. So just like the above, we just do this 12th sum also. Okay, just like the above, we have to find out this x value, but here we have to find out this y value. In the second point, y is given and the distance as usual is given as 10 units. Okay, just like the above sum, we just do this 12th sum also. Okay, it is very easier. We just do with your own and check your answers at the back of your textbook. Okay, 13th sum. Now it's time to explain 13th sum. So find the radius of a circle whose center is. Now we have a circle first. So we have to find out the radius. Here it is the radius. This is radius. Yes, whose center is? Here it is the center, that is C 3, 2. Whose center is 3, 2 and passes through this point. Passes through the point, that is P minus 5, 6. To find out this radius, we have to find out the distance between PC. That's it. Very easier. Given that the center of a circle C is 3, 2 and it passes through P minus 5, 6. So what is radius? Radius we have to find out. Okay, the distance between the radius of a circle is equal to, is nothing but a distance between PC. Distance between PC. What is P? What is P? Minus 5, 6. What is C? 3, 2. Let us take these points as x1, y1, x2, y2. That's it. That implies square root of x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of 3 minus of minus 5 whole square plus 2 minus 6 whole square. That implies square root of 3 plus 5 whole square plus minus 4 whole square. That implies square root of 8 square plus 4 square. That is equal to square root of 64 plus 16. That is equal to square root of, by adding of these two, you will get 80 units. That's it. If you want to take it out, so you will take the as usual, just if you want to leave it, leave this like this. Otherwise you can take the number from the inside. just like 4 into, we can write it as 4 into 20, right? So that implies square root of 4 into 4 into 5. 20 we can write it as 4 into 20. That implies square root of 4 square into square root of 5. That implies square root cancel 4 root 5 units. That's it. Okay. Here, look at here. It is finished. So it is radius of a circle. Radius of a circle. Here it is finished. Right. Now 14th sum is just like in the part 1 and part 2 I said to you about the collinear, right? 3 points he was given. Is this 3 point which forms a triangle? Here he was asking to us, right? When the 3 points which forms a triangle, if it is not collinear. If it is not collinear, then it forms a triangle. Otherwise, it will not form a triangle. What is the collinear condition? So let us take these points as A, B, C. What is the condition for the collinear? Condition for collinear is AB plus BC is equal to AC. If AB plus BC is equal to AC, then it is collinear. Then the points which not forms a triangle. If AB plus BC is not equal to AC, then it forms a triangle. Then it forms a triangle. Okay? Then it forms a triangle. So you have to check, you have to do the distance between formula for AB, BC, CA. And then you just check the condition of this collinear. If you will check the condition of the collinear, if it satisfies this one, then the points which not forms a triangle. If it is not satisfied, then it forms a triangle. That's it. Okay, you just do by your own. Already I said in the part 1 and part 2 of this coordinate geometry. Now I will explain this 15th sum. So here the last sum is 15th one, that is find a relation between x and y. Is you heard this kind of problem in the examples? Yes, in the part 2 we have like this, right? Example 8. Example 8, find the relation between x and y such that the point xy is equidistant from the point minus 2, 8 and minus 3, minus 5. Okay, let us do this one. So given that the points are A minus 2, 8, B minus 3, minus 5. These two are equidistant. The points are equidistant with P x, y. P x, y. So equidistant means, so hence AP is equal to BP. That implies distance of AP is equal to distance between BP. What is A? Minus 2, 8. What is P? X, y. Here what is B? Minus 3, minus 5. What is P? X, y. Let us take the values as x1, y1, x2, y2. x1, y1, x2, y2. What is the formula? Square root of x2. So for both of this, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here also we have same, that is x2 minus x1 whole square plus y2 minus y1 whole square. That implies square root of, you just substitute these values. Okay, what are the values? Here x minus of minus 2, y minus 8. X minus of minus 2 whole square plus y minus 8 whole square. Here x minus of minus 3, y minus of minus 5. X minus of minus 3 whole square plus y minus of minus 5 whole square. Okay, squaring on both sides. That implies square root of x minus of minus plus 2 whole square plus y minus 8 whole square. That is equal to square root of here x plus 3 whole square plus y plus 5 whole square. So squaring on both sides, no, square. Here also square. Square root cancelled. Square root cancelled. So for only for the eliminate this root, we are taking it as squaring on both sides. Okay. Here x plus 2 whole square plus y minus 8 whole square. That is equal to x plus 3 whole square plus y plus 5 whole square. That implies here we have two types of formulas. That is a plus b whole square, that is equal to a square plus b square plus 2ab. We just write at the column. Okay, a minus b whole square is equal to a square plus b square minus 2ab. Okay, by using of these formulas you just elaborate this just like the formulas. A square plus b square plus 2ab. Just I am writing this one as a square plus b square plus 2ab. Here this one also a minus b whole square, a square plus b square minus 2ab, just like that. Here that is equal to a square plus b square plus 2ab plus, it is also in the form of a plus b whole square, a square plus b square plus 2ab. That implies x square plus 2 square means 4 plus 2 2's 4x. Here plus y square plus 8 square means 64 minus 16y. That is equal to this one, x square plus 9, 3 square means 9 plus 2 3's 6x plus y square plus 5 square means 25 plus 2 5's 10y. Just bring this all into one side. That is equal to x square plus 4 plus 4x plus y square plus 64 minus 16y. The signs will be changed into other side, right? Minus x square minus 9 minus 6x minus y square minus 25 minus 10y is equal to 0. Plus x square minus x square cancelled. Plus y square minus y square cancelled. Only the x terms you just look after here. Here we have only two terms of this x terms. That is plus 4x minus 6x. We have to subtract this 4x from 6, but we just remind this minus 2x, and y terms this one and here this one, so these two. So we just look after here minus 16y minus 10y. Okay, minus, both you have to add 16 plus 10 26y. Both you have to add, but the signs are same. Okay, next constants. 4 plus 64 68 plus 64 68. These two are plus signs, these two are minus. Okay, minus 9 minus 25 minus 34. That is equal to 0. That implies, okay, minus 2x minus 26y. When you subtract this 34 from 68, then you will get 34. That is equal to 0. In 2 table, Okay, in 2 table, you just take the common as 2. Minus 2 I am taking. Minus 2 I will take the common. Okay, x plus. So in 2 table 26, 13 times, minus in 2 table, that is 17, that is equal to 0. So you just take this 2 into other side. X plus 13y minus 17 is equal to 0 by minus 2. That is equal to x plus 13y minus 17 is equal to 0. That implies the equation which becomes x plus 13y is equal to 17. It is the relation of this x and y of this sum. Okay. So here we finished this 15th sum also. Here we finished this 15th sum also. Okay. Tomorrow I will give the next introduction part of this section formula, as well as this midpoints, as well as the centroid. On the basis of these 3 formulas, we are doing this 7.2 exercise. Tomorrow I will give the introduction part of this 7.2 exercise. So you just do all the sums carefully. What I am giving here for the homework, do very carefully. It is very easier sums, but somehow it is lengthy. Okay, thank you.